Solving a fun probability puzzle by Martin Tutorials. And a quick announcement, do you have a math-related inquiry? Put it in the comments of my YouTubes. I will try provide a helpful response. It's happened before that a viewer had a question. It was my pleasure to help. And a reminder, I have two YouTubes, Variety and Fun Math and Martin Tutorials. As today's more advanced statistics, it is only going to Martin Tutorials. And on to today's question, or if you pardon the pun, let's get the dice rolling. Okay. Mr. Smith plays a game called Rig Dob Los Dadado. Where did that word come from? I just made it up. If it matches anything, anywhere, in any language, any place, that is pure coincidence. I just made up that word now. So let's get on to the rules of the game. What this game that Mr. Smith is playing, he rolls a dice 10 times. If he rolls a 6, it's called a win. If he yields 2 or more wins with the 10 rolls, that is called a victory. So what they're asking is, with that 10 rolls, what's the probability of a victory? Or I can rephrase that, what is the probability of getting 2 or more rolls? That's part A. Right, so what do we have in front of us? We have a number of events. In this case, it's 10 events. Each event has 2 outcomes. We can call it a win or loss, or success or a failure. It can even depend on your course what you call it. Each event, there's a probability of that win, which is 1 over 6. And in this case also, the probability of a failure is 5 over 6 in this particular question. And we notice that it's the same probability no matter what, and each event is independent of the other. It doesn't matter what happens before, it's still 1/6 chance of winning or 5/6 chance of not winning. All right? What does this tell us? That tells me we have a binomial distribution. We have a whole bunch of events, each with the same chance of winning, and one does not have an effect on the other events. All right? As a reminder, that's the formula for binomial distribution. And of course, the letters might vary depending on the book, the course, or where you're learning. And of course, I always stress, if you're doing a course with an instructor, I want you to use the terminology of your instructor. And in this case, X is the number of wins or successes. N is the number of trials. P is the probability of a success. In this question, it's 1 over 6. And in this question, Q, which is a probability of a failure, is 5 over 6. So that's the formula where we plug into. So we would plug in a 10 for N, 1 over 6 for P, 5 over 6 for Q. We plug a 10 in for whatever N is, and X is the number of successes we want to calculate, the probability of that number of successes. All right? If I had lots of time, I could draw this chart 11 times. That formula, I could say, what's the probability of no successes? What's the probability of 1 success? What's the probability of 2 successes? All the way until 10 successes. And with each one, I'd plug in that number for X. So if I said, what's the probability of 4 successes? That's rolling that dice 10 times and getting that 6 4 times. I would plug a 4 in for that X. Now, just for the records, if I had to do this 11 times and add it up, what do you think I would get? It would all add up to 1, because that's 1 is like saying 100% certain. The probability of all these results added together, I'm absolutely 100% sure I'm going to get one of these. So all of these will add up to 1. Now this question said, what's the probability of getting 2 or more successes? What I could do is work this out for 2, work it out for 3, work it out for 4, all the way until 10. And if my arithmetic is correct, that would give me the correct answer. But I think it's much quicker to work out the probability of 0 and the probability of 1. Once I get that answer, I say 1 minus that answer, because everything here adds up to 1, and these two totals plus all those totals add up to 1. So 1 subtract these two totals will give me all the rest, and the rest is getting 2 or more successes. Both methods are correct, but doing it the reverse way is actually much quicker. So there's a reminder of the formula, and we're going to work out the probability x equals 0 and probability x equals 1. We plug in where n equals 10. For p, it's 1 over 6. Q of a failure is 5 over 6. And the probability of 0 successes is 10, choose 0. It's 0 up here. And 10 minus 0, which is 10. The probability of x equals 1, I use the same formula, but I plug a 1 in for x. And here, q is 5 over 6, and n is 10, 10 minus 1, which is 9. And if I do the arithmetic with a calculator, the probability of x equals 0 is 0.1615. I could even write it here. And the probability x equals 1 comes to 0.3230. And of course, I rounded up to 4 digits. There are actually more digits. And if I add the two together, I get 0.4845. 0.4845 is the probability of getting 0 sixes and the probability of getting 1 6 added together. That means the probability of getting more than 1 success, which means 2, 3, 4, all the way until 10, would be 1 subtract 0.4845. The probability of 2 or more wins is 1 minus 0.4845, which is 0.5155. And we called it a victory. That's the word we used for getting 2 or more successes. The probability of victory is 0.5155. So that answers that question. Now let's get to part B. They brought in a new rule. It costs $5 to play the game with 10 rolls. A prize is given for victory. If you get that victory, you win a prize. Mr. Smith wants to play many, many times. What should the victory prize be so that in the long term, Mr. Smith will likely not win or lose, but stay the same financially? Okay, so he puts in $5, and after 10 rolls, he might win a prize, depending if he gets 2 or more sixes. So let's tackle that question. You see, I wrote this formula and I'll explain why. I said $5 equals 0.5155x, where x is the prize he wins. The average prize is the price times the probability. I'll use simple numbers. If you play a game and you win $4, if you win, and you've got a 50% chance, a 0.5 chance of winning, your average win will be 0.5 times 4, which is an average of $2. His average win, if he wins X, if he gets 2 or more sixes, the average win per game is X times 0.5155. And that X times 0.5155 equals 5. Using equation rules, I divide each side by 0.5155 to solve for X. I get 9.6993 to 4 digits. And using dollars and cents to the nearest penny, he should win $9.70. That means if every game of 5 rolls, he puts in $5, and if he gets what we call the victory, that's 2 or more sixes, he wins $9.70. It means if he keeps playing this game over and over again, on average, he will stay the same. He won't win or lose. That's the answer, $9.70. And thank you for watching. And please click subscribe. Thank you. If you enjoyed this mathematics, click subscribe. And if you did not enjoy it, you also encourage to click subscribe. Take care.